Welcome back to the physics class. Today we shall discuss about the average and the mean life of radioactive material. It is either called as an average life or the mean life. Another related measure is the average or mean life, that is denoted by tau. This again can be obtained from equation. This we will derive and see. The number of nuclei which decayed in the time interval t to t plus delta t is given by this formula, which is our n, lambda n, that is activity. Each of them has lived for time t. Thus, the total life of all the nuclei would be t lambda n naught e raised to the power minus lambda t into delta t. What we are doing here is we are taking the mean of all the lives. It is clear that some nuclei may live for short time while others may live longer. Therefore, to obtain the mean life, we have to sum or integrate this expression over all times from 0 to infinity and divide it by the total number n naught of the nuclei at t is equals to 0. This is exactly what we do in mathematics when we want to take the average or the mean. Say you have some numbers, 5 numbers, 1, 2, 3, 4, 5. You want to take mean of these numbers. What we do is we write 1 plus 2 plus 3 plus 4 plus 5 divided by 5. So what we are doing is we are taking the sum of the numbers and dividing it by the total number, that is 5. Here also we are doing the same. We are looking out for mean life, so we are taking the sum of all the lives and we are dividing it by the number n naught. The mean life of a radioactive substance is equal to the sum of number lifetime of all the atoms divided by the number of all atoms. So mathematically it is tau is equals to lambda n naught integration of t e raised to power minus lambda t dt. Now why we have taken integration? Because it is a very long time from starting from 0 to infinity, and we cannot practically add all the lives, infinite lives. Thus, we use the mathematical tool of integration, which will give us the total of all the lives. This numerator is then divided by n naught, which gives us the mean or the average. After cancelling n naught, we see that tau is equals to lambda integral of t e raised to power minus lambda t dt, and the limits of integration is from 0 to infinity. One can show by performing this integral that tau is equals to 1 by lambda. Now we shall see how we get this equation. Let's derive.
The derivation of the mean life starts from this equation. Left hand side is tau, which is the symbol of mean life, which is given by lambda integral of t e raised to power minus lambda t dt. Now we will integrate this. In order to integrate, we will use a formula from integration which is called as integration by parts. Because there are two terms on the right hand side, we have to use integration by parts. So let us see how it goes. Here, lambda remains outside the bracket, and the first term on the right hand side after integration would be t integral of e raised to power minus lambda t dt minus of integration of differentiation of the first term, that is t, and again integration of e raised to power minus lambda t dt. This is how the equation goes. Now here, when we integrate, e raised to power minus lambda t, it is e raised to power minus lambda t upon minus lambda. We have to put the limits here. So it is 0 to infinity. So limits remain 0 to infinity. Differentiation of t is 1, dt upon dt is 1, and integration of e raised to power minus lambda t is again this. Now, when we integrate here, we see that this term becomes 0, because when we substitute t as infinity and 0, the first term totally becomes 0. T also takes the value, and the second term is plus 1 upon lambda. Integration is e raised to power minus lambda t upon minus lambda between the limits 0 to infinity. This gives us lambda 0 plus, it is minus 1 by lambda square, e raised to the power minus of infinity, that's the upper limit, minus e raised to the power 0, that is the lower limit. So we see here it is lambda into minus 1 by lambda square, and now e raised to the power minus infinity is 0, e raised to the power 0 is 1, so we have this term. It is lambda into minus 1 by lambda square into minus 1. So this gives us, after cancellation, it is 1 by lambda. So we write the mean or the average life tau is given by the reciprocal of lambda, that is the decay constant. So mean life is nothing but the reciprocal of decay constant.
Thus we see that half-life is given by log of 2 upon lambda, which can also be written as tau log of 2. This is in terms of the mean or the average life. So this is a relation of half-life with the average life, that half-life is equals to average life multiplied by log of 2. This completes the topic of average life or the mean life. Do practice this derivation, although it is more of mathematical. You need to know the basic theory of integration, how to apply and get the formula derived. That's all for today. Thank you.